All right, everyone. Welcome to another Manufacturing Millennial live webinar. I'm Jake Hall, and with me today is Patrick Templeton from Omni Labs. He is one of their additive manufacturing engineers. And today we're going to talk about how additive manufacturing, a very common topic and discussion right now, especially in Industry 4.0 and just the market as a whole, is really impacting and really transforming market strategies. So what this webinar is not today is necessarily talking about the different types of additive manufacturing processes that are out there and what process is best for you. What we're talking about today is really how additive manufacturing is transforming businesses and how they approach go-to-market strategies and how they are approaching manufacturing their products. So really exciting stuff today. I actually have one of Omni's robots behind me, which we'll talk about. But let's go ahead and kick off. Patrick, thanks for being on today.
Well, thanks for having me.
Absolutely. So you have a lot of experience with additive manufacturing, and you work for a company in California called Omni Labs. Can you tell me what they are, what they do, what they make, and we'll jump right in. And at the same time, I'm actually going to pull up and drive around the robot while you're talking.
All right. So we are a robotics startup. We're based here in Silicon Valley, California, and started in 2015. And overall, our goal is to, what we want to do is develop robots that facilitate human interaction rather than like replacing people, which is what I think a lot of people fear with robotics. And as Jake is driving around there, that's our flagship product called Omni, the Omni Telepresence Robot. And what that does is allows you to be present in a different location rather than it's a more richer experience than like calling someone or like a video call. You can actually drive around, you can interact with people, and you kind of have a physical presence in a way that that phone calls just don't have. And also, sorry, go ahead.
Oh no, go ahead. Sorry.
I was going to say we're also unique in the sense that we do 3D print most of the parts on the Omni robot, and that's what I do here is run the 3D printing, everything under the 3D printing additive manufacturing umbrella here at Omni Labs.
Fantastic. So it's really exciting. Additive manufacturing is something that I've been passionate about and I've been playing with more. And why did Omni Labs, when they started their company and they said, hey, we want to make these telepresence robots, which can really take something a lot more than a Teams meeting, and a face-to-face, but have a robot that I can drive around on a factory floor or in a warehouse and view something that, wouldn't normally be capable with the normal Teams. Or if I want to do a site assessments, or I want to know why is a machine down and I'm a plant engineer, instead of having a guy calling him, I can just log into a robot and drive it out on the floor and see the status of the machine. What was the reason for OmniLab choosing, additive manufacturing as their base and how they're going to manufacture it versus other processes that have been around and used in robotics for 10, 15, 20, the past 30 years?
Right. Well, there are a couple of reasons. So early on, it was really I would say in no small part a matter of just practicality. We were started in essentially a garage, and you really can't fit a lot of equipment in someone's home. So 3D printers are a great way to utilize a small amount of space, and they also allow us to scale up over time very easily. You just add more printers and you have more printing capacity. And it also works well with our design approach. So all of our founders have a background in software development. So we do take like agile software development principles and we try to apply that to hardware. And what that means is that we can, rather than spending a lot of time up front to develop a very finished product, and then you take that to injection molding or whatever process you use. 3D printing allows us to iterate like over time, so we can start with a base level product, a minimum viable product, and we can test it out. We can hold it in our hands and expand from there.
Absolutely. So as you mentioned, this idea of additive manufacturing coming from like a software perspective is robust, right? Something doesn't work, you just simply delete a few lines of code and you start fresh, and you didn't lose a lot of invested time like you would with other mechanical processes. So I guess one of the biggest questions that I always get in saying, does additive manufacturing make sense for go-to-market products outside of what we think of as a hobbyist perspective? I have a 3D printer behind me from Slant 3D, and I 3D print stuff for fun because I want to learn more about the technology. I have a SpaceX Falcon Heavy behind me. I have the T800 from Terminator right here. And I use it to print hooks for my Chicago Cubs hats and make blocks and fidget spinners. What are some of the negative reputations that I think people perceive that additive manufacturing has? What additive manufacturing is in terms of products in the industry, and what would you have to say about those being incorrect?
Sure. So I think for a long time, additive manufacturing has actually been around in some form or another for quite a while. So you'd have these kind of huge like Stratasys machines. It's like the size of a refrigerator, and it's $100,000 or something. And that was useful in certain like niche applications as like a prototyping tool, as a like model making kind of thing. But it just really was not approachable for your average like hobbyist or like a small company, or something like that. And there were also like a few like open source kind of DIY things that have been floating around for quite a while. Like the maker community has been interested in 3D printing for quite a while, for printing Terminator skulls and all kinds of cool stuff. But I think for a long time, like it just wasn't quite on a level where you could produce a good that is going to go to a consumer, and people pay a lot of money for our robots, and we like them to look nice, and we like them to be consistent and quality. So
I do that as well. When you look at quality, and my webcam is obviously not going to show that, but when you look at quality and the fact that this base is completely manufactured and 3D printed. And we got some videos we'll show in a little bit. And I think you actually have one of those bases behind you. The fact that a plastic part of that size, where you would have to injection mold it, and you would have to develop the tool, and as your models change, it's a lot of engineering costs. It's a lot of materials cost to produce something of that size and scale. So I think, that's another thing of, I have this very robust, it's a thick base. I even had my 2-year-old daughter, or excuse me, my 18-month-old daughter sitting on it for a minute, and I was driving it around because it can handle that weight capacity. It's not something where we think of as a fragile plastic anymore. And I think that, later on we were going to talk about materials, but I think it's a good point now. The materials we're using this is not something that we just think of as this super cheap, breakable, it's you drop it, 6 inches just going to shatter apart. I think the overall technology around 3D printing, would you say has really evolved in the last few years as well, in terms of being able to make a much more robust product?
Absolutely. So I think once so probably about like 10 years ago, there were a lot of patents that expired, and then you did have these kind of hobbyist level 3D printer companies kind of crop up. And then you just have a whole ecosystem surrounding that. So just everything, like the hardware is so much better, the software, the material science, as you mentioned, like around the plastics is just exploded. For a long time, people were printing with like weed trimmer wire, like ABS weed trimmer wire, and like salvaged stepper motors from VCRs and stuff. And it's absolutely evolved like crazy.
Interesting. That's really cool. So for those of you who are joining us late, Jake Hall, the manufacturer millennial, I'm here with Patrick Templeton. He's the additive manufacturing engineer. We're talking today about how additive manufacturing, 3D printing is transforming market strategies. Really, from a business perspective, for companies who are in manufacturing, why would I look at using additive manufacturing as a production method versus other methods that are in the industry? And for those of you who are in chat on YouTube and LinkedIn, if you guys have questions along the way or want to make comments, we have here on the side everyone's chat that's live. So if you want to say hi and get a shout out on LinkedIn, we'll bring up your comment and your name. But if you have questions for Patrick or myself, if I can answer them in any way, please feel free to comment on them. And we're going to continue on with the conversation. So OhmniLabs is manufacturing telepresence robots. You have 4 or 5. How many different models do you think you guys have currently?
Of robots?
Yeah.
So our, as I mentioned, our flagship product is the Omni robot that you have behind you there. And what we like to do is we take that as like a base platform, and we can take everything on that works well. And because we can use 3D printing, we can make like low volumes or like prototyping, and we can expand on that and create all kinds of other things. So we have we have a you may be familiar with our Gilt Edge soccer the soccer VW robot. So that was all that was a huge 3D printing project. That entire robot was 3D printed. We have we have a newer product coming out that's a UV cleaning bot. So what we can do is use the it uses a lot of technology carried over from Omni, but we can use it for more like industrial applications.
Mm-hmm. Yeah, because I think of one thing with the UV robots out there. A lot of times they're put on autonomous mobile robots, AMRs, and those applications can be very expensive in terms of price. And the one thing about UV sterilizing is a operator or a person can't be present to that UV light.
Exactly.
But you could easily go in and clean a room and drive a robot around on your computer and see what's happening for a relatively low cost for UV sterilization. So just a quick comment. So here we go. Quick comment. It's about the value of the application ends up bringing to your organization in the end. Mm-hmm. Absolutely. That's a great point. So a couple of things that I think of with additive manufacturing, it's a very quick, building process in a sense. I can design a part on my computer. I can throw it into a slicing software where it slices up the individual levels, and I can then print a part and have a part ready with me within just a few hours in some applications. And that's the one thing I think from manufacturers' perspective is the supply gap. And we really felt that when COVID hit last year, and we're still feeling it in a lot of areas where a lot of components manufacturers were waiting to come shipped over from China or from overseas or from other manufacturers in other locations to get product at them. I think one thing that when you said as an OhmniLab and as a company, well, we're just going to manufacture everything in-house at a relatively low cost, we're really eliminating the supply gap and the demand that other manufacturers could face with similar products. Can you talk more about the supply gap and kind of the strategy and the advantages that additive manufacturing brings to those companies?
Sure, and you're exactly right. That is unfortunately, we weren't completely immune to it, but 3D printing everything in-house, we don't 3D print everything, of course, unfortunately, but for all of our 3D printed materials, all of our 3D printed parts, we do, as you can see in the video there, we manufacture all of that in-house. And so what that allows us to do is, rather than having to deal with like all, shipping and supply of all of these different parts, all we need is filament, and we can just make whatever we need on demand. So it's a very lean process. It allows us to adapt to whatever changes come our way. And as we can see here, there's a variety of components that are being manufactured. You have all of your, material laid out just in a nice. It's a printing farm in a lot of applications. So, how many printers do you guys have on site? So we're always building more here and there, but we actually have over 120. So that's so most of our printers are those ones that you see there. They're I would say roughly like a normal size for what you would see in like a consumer grade 3D printer. And then we also have some large format printers that are over on the right side of this video here coming up. And
yeah, absolutely. So another comment that came in, this is from Dean. Additive manufacturing is critical for us at Rapid Robotics custom fixtures, grippers, and every deployment. So yeah, there's another great example of, end of arm tooling is something I see in a lot of applications where you can now print end of arm tooling at a rapid pace. So especially for prototyping, I remember walking into some machine builders and seeing 5, 6, 7 different iterations of gripper mechanisms to grab these components that they did within a 48-hour period of time.
Mm-hmm.
And I think the other thing that's really unique about additive manufacturing is the cost. So let's talk about the development of, I'm just going to pick an example, the base of the robot. We want to know what assembles bestly, how do these snap hooks and everything work. You can print how many different iterations with a 0.5 millimeter variation between component to component to component, and you can see what works right away. You want to add a little bit more just on the cost savings that you can have with rapid production of variation?
Yeah, that's exactly right. We can do a lot of things in parallel. We can try maybe, so if you're getting something like machine, for example, oftentimes like it takes a lot of iterations and to go back and forth with your machinist supplier to get exactly what you want. You have to try things out. With 3D printing, and especially with having it in-house, we can just, if we have an idea, we can just kind of throw something on the printer, try it out, try several things in parallel, and just see what works best. And we can have that. We can start something and come in the next morning and have 5 different ideas ready to test, and that's exactly what it allows us to do, is just iterate much quicker than traditional methods.
Yeah, and I think that's a great part when you kind of said came in the next morning. You could have a farm printing dozens, if not hundreds, of components, because that's the one thing as well on a bed, which we saw in some other applications. I think in some of the videos, we can have a farm like this printing smaller components and print 30 or 40 of them at a time on a single bed. So you can walk in the next morning and have hundreds of parts completed that don't need operator tending. You just set up the component, you set up the part, you send the 3D printer the file, and you could have lights out operations in a lot of applications where typically injection molding is something that needs to be handled by an operator.
Exactly.
So that's really cool. I'm showing up some more videos along the way that people are seeing, and I love highlighting this. I love this view in general. We just think of something where it's really to scale. When we talk about additive manufacturing farms, this is one that comes to mind. Slant, who sent me the 3D printer, all they do is just make parts. They don't make robotic systems or anything like that. They just simply print hundreds and hundreds of 3D printed parts. And that's what you guys are doing here. So really to talk about our next system, what are the types of printers? We're viewing some printers here. What is the size envelope that I'm printing right here? Because what I want people who are listening to the webinar to think is, well, that's great printing small components, but what if I need to print something a lot larger at scale? What printer sizes do you guys currently have at site at OhmniLabs? And, what if you needed more printers? What do you guys do?
Sure. So as far as the size of our printers, so those ones that you're seeing now are 300 by 400 millimeters is the bed size. And that's, as I mentioned, like that's roughly comparable to most kind of larger printers that you would see, like off-the-shelf printers. Mm-hmm. Your CR10s. It's a little bit bigger than a Prusa. So those are what most of our printers are. And then we also have, so this one here is a large format printer. That one is 500 by 600 millimeters, I believe, is the bed size, and that lets us print. I have one of those here. You can see it's pretty big. It's very quite sturdy.
Yeah.
That print actually takes about 6 to 8 hours. I want to say maybe 7. It is about the print time on one of those. The sidewall is what we call it.
So we have these take 6 to 8 hours to print, a long time. What happens if OhmniLabs sees a huge increase in business because a large company wants to buy these robots and they need it within a certain time? How does a company or a manufacturer respond to an increase in demand? Because traditionally, if a company came back and said, oh man, we need to put in all these parts, and they look on their floor and say, well, I only have 4 or 5 injection molding machines, mm-hmm. I need to order another machine. And so they'll reach out to figure out, okay, is this injection molding machine coming from Europe? Is it someplace we have to import? Well, you're 40 weeks out to get another injection molding machine to meet your quantity. What does additive manufacturing, because you guys make these printers in the house, how would you respond to that?
Yeah, well, so yeah, you're exactly right. That's a huge problem with traditional machining. So what we do to solve that problem is we just build more printers. So the design is all our own, we unfortunately do not print any metal at this point. I would love to do that in the future, there, Thomas. Anyway, so yeah, what we do if we need more printing capacity, we just expand to more printers. Since 3D printing is a very easily kind of parallelized method that each printer can print any part. So we just expand more printers and then and expand our printing capacity that way.
And I think that's interesting that you mentioned that, where each printer can, print its own unique sets of parts. So here before you had to have a die or mold specific to each component you were printing, where here now you have a universal platform where you can literally print, I don't know how many different components are on, how many different printed parts are on the robot that I have, Patrick?
So I want to say over 60% of the bot is 3D printed, in terms of like BOM. In terms of like number of parts, I'd say 60 to 80. Don't quote me on that, unfortunately. Yeah. But it's quite a few. And we do print those in sets of parts. So of course we don't print each individual part, as you can see on the printers there. And
but I think that's really unique to talk about the diversity of components that you can print in a relatively small area. So especially for small to medium-sized manufacturers who don't have this, 100,000 square foot warehouse facility, you can print a very diverse group of components in a relatively small manufacturing space.
Exactly. I think our 3D printer farm is somewhere around like 800 to 1,000 square feet. So it's very, very small by most standards. And we can print, if it will fit on a printer, we can make it. It's very, very easy to modify our designs to expand to new printed parts, and yeah.
Yeah, and that's what's really exciting. I think that's why 3D printers give a advantage to scale for a lot of manufacturers. And I think that's one of those things when it's transforming your market strategy as small to medium sized, companies say, oh, we want to manufacture this new component. Or it's not necessary if you're making products, but if you're buying components. There was a really interesting study or an article that I read. It was either from Ford or GM, where they were buying these components for $100+ a piece, and it was a hook that went on part of their chain line in their automotive facility. And they were buying these components, and it took a lot of costs. And one of the engineers, who is 55, 60 years old, so that's another myth that I wanted to dispel. Additive manufacturing is not something that you need to be this young, person who's fancy with computers and stuff like that. Additive manufacturing is so simple these days. It's really not a steep learning curve. I brought my printer home, and I had a Falcon Heavy that has, about 100 different components on it printed within the weekend, just because of how easy it was to start up. It was my first printer. And I think that's another thing as well, is with other processes, there's a lot of information you need to learn about an injection molding, the temperature, the feed rate, all these different resins and processes. And there's a lot of risk and resources invested versus a printer. I don't want to say it's impossible to screw up your print, but I want to say it's a lot more controlled of a manufacturing process than other ones out there.
Absolutely. So yeah, as you mentioned, it is really easy to get started. One of the worst things that can happen with the printer, like worst case, you mess up the part, clear it off, and fix the design, fix the settings, and try it again. And we certainly do a lot of that here. I think we're at a point where most of our parts come out pretty good the first time, but we still do definitely have to go through some iteration steps. And it's much easier than like a CNC machining process or injection molding or something, as you mentioned.
So let's talk about quality for a second. You talk about different iterations and stuff like that. People think of, well, hey, you're printing a part, it's not coming in as a solid injection molded part. How do you meet the quality and the tolerances in 3D printing, and how do you check that and confirm that? And I think, let's see, I think there was another one here. Would you recommend for tight tolerance metal 3D printing? I don't have a lot of examples. I know I have some connections in the industry who do 3D printing. Pat, have you had any experience with 3D printing as a whole and recommending tight tolerances?
So I haven't personally used a metal 3D printer. I hope to one day maybe. But yeah, it's an entirely different beast from like FDM printing. I think tight tolerances, yes, generally, like they're much more of an industrial tool right now. It's not really something that your average consumer would be able to just jump right into. It's still very much kind of a work in progress.
Yep. But I know, Thomas, if you want to reach out to me afterwards and message me, I can definitely put you in a touch of a few people who are using additive manufacturing. One of them being, I know, Honeywell Aerospace, John Hobgood out at Honeywell. They have an additive manufacturing lab that they are 3D printing metal components for the aviation industry and a lot of other cool stuff. So reach out to me afterwards, and hopefully I can get use some examples about metal additive manufacturing. So one of the other things, we talked a little bit about the quality. I want to talk about spare parts, because that's another thing that when a operations manager or a leader in the company says, man, we have so much inventory just sitting on our floor, which is just dead money that's just sitting there. How does OmniLab, as a additive manufacturing, company who is making their components, approach their crib and spare parts differently than what other companies would?
Sure. So 3D printing, and especially 3D printing our parts on site, allows us to just be very, very lean. Rather than having to wait on parts to be shipped from an offsite facility somewhere, we can. So we do have a little bit of a buffer just in case. But in general, like, we can print parts on demand. Our 3D printer farm is designed to outpace our assembly line, so we can always supply them with fresh parts, and then in case we do have a broken part or something like that we need to replace, we can always do that.
Yeah. So here's a couple of other ones. So here's a question, and I don't know if you experience. What do you think about printing finished consumer electronics using OhmniLabs, SLS versus? So let's talk about the material SLS versus SLA. What material do you guys use for a lot of the components that you guys print?
Yeah, so we use only FDM printing here at this point. We do use a few different plastics. So we use PLA, PTG, and then we'll use a few others, like in more specialist cases. But generally, there's a trade-off with other materials.
Absolutely. And just a couple of other comments that we get through here. Megan said, Superior Joining Technologies also uses metal additive manufacturing for aerospace. I mentioned Honeywell, but it sounds like another company is using that out there as well. Andrew said, check out Mark Forge for metal 3D printing. And looks like Superior Joining is located in Park, Ohio. So Illinois. So I might have to drive out there and check it out sometime. So one of the things for companies who have used old manufacturing processes in the past and want to explore additive manufacturing, where do you recommend that they start in the process? I mean, do they just go out and buy a 3D printer? What questions do they learn, or what questions should they ask to say, hey, is additive manufacturing a right choice for me with what I'm trying to do?
So I think pretty much any like hardware company is going to benefit from 3D printing in like the sort of conceptual to R&D stage of things. So you're exactly right. You can buy a 3D printer. They're as you mentioned, they're relatively easy to set up and get going with, and you can just take that and run with it. You can very quickly take something from just like a CAD design. Like our industrial designer uses a lot of 3D printing to just print out like it is a good way to get like an idea for like the look and feel of something. It's much easier to kind of, you can hold something in your hand, you can see how it looks in in real life in 3 dimensions rather than just looking at drawings. So it lets you, lets you iterate a lot faster. And then of course the prototyping angle is where 3D printing has always come in really handy, and allowing you to just try out ideas, and that will work for really pretty much any use case I can think of in terms of like hardware manufacturing companies. And then as far as like production, that may be a little more situational depending on what kind of product you're making. But I think 3D printing works very well, especially like getting started, in your initial phases of like lower volume production. It works very well.
Yeah, and I think that's just one of those components where it's a relatively low investment. I mean, I know metal manufacturing is another beast in its own, and I personally want to learn more about how metal additive manufacturing is transforming business strategies. But as far as components here, you can go on Amazon and begin printing your components for testing or building small fixtures for $300, $400 for a relatively low cost printer. And of course, there's many other processes out there and materials. Like I know a couple of things were mentioned, like Mark Forge and OhmniLabs out there that are definitely more consumer, products that you can invest a lot more money in. But I think that's another thing as well that is really good to mention is it's a relatively low risk cost to invest in printing components.
Absolutely. It's as simple as just buying a printer and playing with it, getting started with it. Very, very simple, very low risk. You can try things out. You can experiment in ways that you really couldn't do with like injection molding or CNC machining, things like that.
Absolutely. So if we'll look at the chat for a little bit more, if there's any other questions that we can help answer or just comments with either what OhmniLabs is doing with their telepresence robots, which I had driving around me, which can go from different facilities and hospitals and schools. And in my case, I brought a few to manufacturing floor when I wanted to view some machines. When I was in a different state, I could drive around and see what the status of that machine was. Patrick, what are some questions that you wish I would have asked you? Is there a question out there that you said, "Oh man, Jake, I wish you would have asked me more about this"? That you want to add?
Well, I can talk all day about anything 3D printing related. So that's a hard question to answer. I will say that for us anyway, our 3D printer farm it's not just about the printers themselves, which is the most I guess obvious part of that, but you can see that we think of it as the entire farm. So we have software, we have like everything from the wiring, the electronics, and powering over 100 printers is certainly an issue in and of itself to overcome. And I think that for at our scale, like it's much more about all of the kind of holistic approach to all of the different things that we do here.
Absolutely. And if people want to know more about OhmniLabs and telepresence robots, how do they get a hold of you, Patrick? Or how do they get a hold of OhmniLabs?
The easiest way is you can visit our website. So it's just OhmniLabs.com. There is an H in there, so you can check the spelling here if you need. And check out our website. You can find me on LinkedIn, on all the usual social media. As I think there was someone mentioned that we are always hiring. So if 3D printing and robotics and things like that are something that are interesting to you, then please contact us. I think jobs@omnilabs.com. And we'd love to hear from you.
And if you want to drive a OhmniLabs robot, which like one I have behind me, or when I first was introduced to OhmniLabs, I had the opportunity of like 30 different robots to print in your lab. Reach out to me, reach out to Patrick, go on OhmniLabs website, and you guys can take control of a robot, drive it around, and see what it's like to drive a telepresence robot and have a conversation like you were in person. So once again, thanks everyone. Patrick, thanks again for being a part of the stream and talking more about additive manufacturing and how it's impacting and changing how companies are really going to market.
Absolutely. Yeah. Thanks for having me.
Perfect. Well, until then, guys, thanks again for joining us, and we'll catch you on the next live webinar.